So the problems we're going to look at now is how to solve problems that have radicals in them. And remember, radicals just means like square root signs or something like. Technically, it could also mean anything with like blah to the 3/2 or blah to the 6/5 or whatever. But generally, whenever we see radicals, we're going to see them as square root signs. So the biggest thing that you want to remember when you're problem solving with radicals is you always have to check your answer, because through the process of solving these problems, we can actually introduce answers that are not really there. You always want to make sure that your solution matches up with the original problem that you have. So more of a typical problem that you can already solve would be something like this. If I said that the square root of x is equal to 5. Okay, you should be able to solve this just by looking at it, hopefully. So you kind of muddle around your brain a little bit, and hopefully you can come up and say, oh, okay, so that means that x must be equal to 25, right? Because the square root of 25 is going to give me 5. Sweet, right? Okay. So I could, do variations on this theme. I could say, well, let's say that x plus 4 square root is equal to 5. And you could say, oh, okay, well, that must mean that x has to be 21, because that would give me 21 plus 4, the square root of 25, is equal to 5, and you're good to go. Okay? So that's all well and good, but eventually you're going to get something that's a little bit harder to solve. So something like, I don't know, something more along the lines of 2x minus 3 is equal to 9. Okay, so to solve that, what you want to do is think about what you did to solve these problems above that line. In this problem, you basically said, okay, I need something, the square root of something to be 5. So really what you did in your brain is you squared the 25 to get your x. And that's pretty much what we're going to do here. Since you have the square root all by itself, what I'm going to do is I want to come in here and I want to square both sides of the equation. Okay? Now I know we've talked about this before. You've been following along with the other videos. Anytime I square a square root, I get whatever I had on the inside. So if I have, 3x square root, if I square it, I'm just going to get whatever was on the inside. Okay? So by that same logic now here on this problem, by squaring the square root of 2x minus 3, I just end up with 2x minus 3. And that equals 9 squared, which is 81. Got it? Okay, now all I have is a reasonably straightforward algebra problem that I would just solve like I'd solve regular algebra. So add 3 to both sides. 84. Divide both sides by 2. And get x equals 42. Does that look right? I think. Okay, so I always want to check my answer and make sure it's right. So let's do a check. So I'm going to say 42, well, let me try this again. I want the square root of 2 times x minus 3 equals 9. I want to know, is that true? So I'll say, okay, this is 84 minus 3, square root of 81, and that indeed equals 9. So I'm good. So that's my answer. Okay? So really, this is what we're going to do to solve all these problems. You'll notice that in this particular problem we were really lucky because the square root was all by itself. So a couple of things you want to check for is, if it's not already, you want to make the square root by itself on one side of the equation. Then you want to square both sides. This actually also works for cube roots and all that, or whatever kind of root. Square, cube, whatever. Both sides. And I'm going to say solve as usual, like you would for regular algebra. And then check your answer. So that's a general strategy that we're going to follow working all these out. Okay, so you'll get the square root thingy by itself. You'll square or cube or whatever both sides of the equation. Solve it like you would with regular algebra, and then check your answer. So there's all kinds of fun you can have with this. So let's just work a ton of examples. I'll leave that there so you can look at it. So let's check this out. Okay, so we've got negative 10x minus 1 plus 3x equals 0. Okay, so looking at that, now we want to make sure the square root's by itself. So we want this guy to be alone. So we're going to subtract 3x and move it over. So negative 10x minus 1 square root equals negative 3x. Right? The next step is to square both sides. Since this is a square root, we're squaring both sides. So on the left, we end up with whatever we had on the inside of the root. And on the right, we have 9x squared. If that's throwing you for a loop, remember that minus 3x squared, I can take that and I can apply that little squared thing to the negative 3 and to the x. So I have negative 3 squared times x squared. Gives me 9x squared. Like that. Okay? So now I want to solve, as usual, whatever that means. This looks like a quadratic equation. So I actually don't want to start with a negative. So I'm going to move everything over to the other side. So I've got this. I'm just going to rewrite it. Like this. Then I'm going to stare at it for a while. Again, remember, you're just taking a problem you don't know how to solve and trying to turn it to something that you do. So you'll look at this for a while and say, oh, I think I remember what I'm supposed to do. Something like this, right? These are both plus signs, so that means these are both plus signs. Since this is a 1, the only way to get to a 1 is a 1 and a 1. And here I can either go with a 9 and a 1 or a 3 and a 3. And looking at it, I think I'm going to go with a 9 and a 1. So 9x and that. Now I can check and make sure it's right first. Outer, inner, last. And that does give me the 9x squared plus 10x plus 1. So that's good. I'm going to go ahead and erase that just because I think I've got too much on the page already. I remember whenever I do have things factored out now, I can separate that out into two equations. Either 9x plus 1 is 0, or x plus 1 is 0. Okay. This is a long problem. So I've got x equals negative 1/9, or x equals negative 1. Now remember what my last step was. My last step was to check my answer. And you always want to check your answer with the original equation. Okay, so my original equation was minus 10x minus 1, the square root of that, plus 3x is 0. So minus 10x minus 1 plus 3x is 0. So I want to plug in each one of these and see if it works. So let's check this one. So I've got negative 10, negative 1/9, minus 1, plus 3 times negative 1/9, and I want to know, does that equal 0? So I've got, it's positive 10/9 minus 1, so I got to get a common denominator. So it'll be 9/9 plus, and that'll be a minus, minus 3/9 is 0. So 10/9 minus 9/9 is going to be 1/9. Minus, that's going to be 1/9, no, 1/3. Remember, I can separate that out. I can already hear you saying, I'm just going to put in the answer and hope I get it right. And in this case, you'd have been okay. So we got that one. So that means that this is a good answer. And then we want to check our other answer to see if it's any good. eventually. Okay. So I now want to plug this in for x equals -1. So I got minus 10 times -1 minus 1 minus 10x minus 1 plus 3 x. And I want to make sure that that's equal to 0. All right, so I've got 10 minus 1 minus 3 squared root. This one goes way faster. And 3 minus 3 equals 0. So in fact, those are both good answers. So I could say that the two answers to my equation, x equals -1/9 and x equals -1. Like that. Okay, so that's the general strategy for these problems, is to get that square root sign by itself. If you can, square both sides and just kind of go to town from there. And again, unfortunately, the best way, not unfortunately, it's probably fortunately, the best way to get good at these is just to do a million of them. So I'm going to throw some up here, have you work them out, and then we'll go from there. Okay? Okay, so here's your list of problems to solve. There's something a little tricky about a lot of them. This one in the back particularly, oops, that's not what I meant to do. This one right here particularly is a doozy. So let me walk you through something right quick that'll kind of help you get started on that. All right? So say I have this, and I have no idea what this answer is going to look like. Okay, so please forgive me. Okay? So what I can do is I can't get the square root by itself. I can get one of them by itself. Like that, right? I mean, it's not entirely helpful, but at least it's something. Now if I square both sides, on the left, of the square root of x squared, which is just x. Now here I'm going to write this out twice. Like that. Okay. Oops, there's my next one to work. So I've got that. Now what I can do is I can FOIL this, right? So then I have 100 first, outer, inner, last, right? Because this, if I have 2x times itself, that'd be square root of 2x squared, right? And then I end up with this. I'm just rearranging the terms. Okay, so now I have a problem where I have exactly one square root sign. So now I actually can get that square root by itself. I'm not going to work this out because this is going to give a really horrible answer. But the idea would be that I could manipulate everything and I could get something along the lines of, 20 root 2x is equal to 100 plus x. So square root of 2x is equal to 100 plus x over 20. Now I can go square both sides again and get rid of the square root. Okay, but like I said, I don't want to actually get an answer for this because it's going to be pretty awful. But you can use that strategy to work this problem right here. So go ahead and give these 3 problems a try and see how far along you can get, and then we'll come back and work them together.
So let's try this. So for this one, the first thing I want to do is I want to get all the x's by themselves. So I'm going to make sure that I go in here and I subtract 5 from both sides. And so I've still got the cubed root of x plus 1 on the left, and 3 minus 5 is going to be -2. Okay, now since I have a cube on the left, now I want to cube both sides. Okay, so I've got x plus 1 on the left, and on the right, remember that's -2 cubed, so that's -2 times -2 times -2, so that's +4 times -2, so that's going to give me -8. Then I'm going to subtract 1 from both sides, and I'll get x equals -9. All right, and of course, I always want to check and make sure that my answer makes sense. So I'm going to say, all right, so I've got the cubed root of, wait, am I incapable of addition? No, I got it. Okay, So everywhere I see an x, I'm going to put in -9. I'll put it in parentheses just to make sure. -9 plus 1 and then plus 5, and I want to know, is that equal to 3? All right, so on the left, I've got -9 plus 1, which is -8, plus 5, is that equal to 3? The cubed root of -8, I just did this, so I should be able to do it backwards, is -2. -2 plus 5, is that equal to 3? Yes, in fact it is, so that means I'm good to go. Okay? And again, I worked this problem like a minute and a half, and when you work it for the first time, it is in no way, don't be frustrated that like, oh, she solved it in a minute and a half and it took me 15 minutes or an hour or 3 days. That's just the way it goes, because it takes a while to get used to it. And like, if I try to, cook a pancake, I would probably not be able to successfully do it in 3 days. So, because I'm not a practice. So just don't get too frustrated if things are taking a little bit longer than you maybe expect they should have. All right. So looking at this one, if you didn't know how to do it before, but now you saw the previous video, or you saw it work the previous example, and you feel a little bit more confident, then pause the video again and try this problem again. But assuming you've done that, then the first thing that we're going to want to do is we're going to want to square both sides of the equation. So on the left, we've got 4 minus x. I'm going to push that down a little bit. 4 minus x. And over here on the right, that's x plus 2 quantity squared, or x minus 2 quantity squared. So remember, you can FOIL it out first. Outer, inner, last. So 4 minus x needs to be equal to x squared minus 4x plus 4. I'm going to flip them so the x squared is on the left just because it makes me happy. Plus 4 is equal to 4 minus x. And then I'm going to subtract 4 and add x to both sides. And then that gives me x squared minus 3x is equal to 0. I can factor out the x to get x times x minus 3. So that means either x is equal to 0 or x minus 3 is equal to 0. So again, I can subtract, add 3 to both sides, and I get that x is equal to 3. Just like that, x is equal to 3. Now I still want to go through here and I want to check. Okay, so let's go ahead and start with checking x equals 0. So the question is the square root of, let's pull this down here, is the square root of 4 minus 0, is that going to be equal to, and again, this is going to be 0 minus 2. So 4, square root of 4, is that equal to -2? And the answer is no, because the square root of 4, if it's just written as the square root of 4, I have to assume that it's positive, so that's actually a bad answer, and I can cross that out. Now I still need to check the other one. It doesn't mean that the other one is automatically right either. So check x is equal to 3. So I have the square root of 4 minus 3, and I want to know, is that equal to 3 minus 2? So on the left, that's the square root of 1. Is that equal to 1? And in fact, it is. So that means that that's a good answer, and I can be confident with it. All right, last one. This one is definitely the funnest of all. So kind of what I was mentioning earlier in the video, what we're going to do is we're going to isolate one of the radicals. So I'm going to subtract root 2x from both sides, which doesn't really seem like it's doing a lot. But this is one of those things when you just have to trust that eventually the math is all going to work out, which is a scary thought, but we just have to try. All right, so now that we've got the square root isolated on the left, let's go ahead and square both sides. So on the left, we just have straight up 2x plus 5. If it helps to write it out again, of course, you can go ahead and write this out. So this over here on the left is 3 minus 2x, or 3 minus root 2x, times 3 minus root 2x. So I can go ahead and I can FOIL that out first. It's going to be equal to 3 squared, which is 9. Outer and inner are both the same. They're both going to be minus 3 root 2x minus 3 root 2x. And then last is going to be plus root 2x times root 2x, which is the same thing as root 2x squared, which is the same thing as just 2x by itself. All right. So I'm going to do another simplification. 2x plus 5 is going to be equal to 9. So I have 3 monkeys minus, negative 3 monkeys minus 3 more monkeys That's going to be minus 6 monkeys. Minus 6 monkeys plus 2x. All right, this is actually kind of neat because some things are canceling out. If I subtract 2x from both sides, that's going to cancel. So that just makes it a little bit easier to look at. 5 is equal to 9 minus 6 root 2x. I'm going to flip the signature, or not the signature, I'm going to get rid of that negative sign, so I can do that by adding 6 to root x to both sides. I have a kitty who's trying to love me, and it's really hard to concentrate on math when you have kitty love everywhere. All right, 5 plus 6 root 2x has to be equal to 9, and I just did that to make it positive. I could have multiplied the whole thing by negative 1, but this makes me happy. Subtract 5 from both sides. Hello, kitty. So I've got 6 root 2x is equal to 4. Okay. Now I'm going to try to get the 6 by itself, which means I need to divide both sides, not the 6 by itself, but the radical by itself. So I need to divide both sides by 6. Kitty, you are not helping. Square root of 2x on the left, and then on the right is 4/6, which of course I can divide the top and the bottom by 2 to get 2/3. So 2x is equal to 2/3. Now, take a deep breath, okay? This is a huge problem, and the fact that you're still here is super impressive. I'm going to square both sides. So on the left, I've got the square root of 2x squared. That's going to be 2x. So that's 2/3 squared. So remember, that's 2/3 times 2/3. So that's 4/9. And then finally, I'm going to divide both sides by 2, or equivalently, I could say I'm going to multiply both sides by 1/2. So I get that x is equal to 4/18. And again, I can divide the top and the bottom by 2. And I guess I could have done that earlier. But that would give me, what, 2/9. So I have x is equal to 2/9. Now we super duper want to box this in, but just to make sure we're good, let's go ahead and check our answer and make sure that it makes sense. All right. So I want to check, I can't spell. I want to check x equals 2/9. All right, so the original problem was the square root of 2 times x. I know you can't see all of it right now, but plus 5, and then plus the square root of 2 times x. And I want to know, is that going to be equal to 3? All right, so we have 4/9. Oh, this is going to be super fun, because 2 times 2 is 4. So we have 4/9 plus 5 square root plus 4/9 square root. And we want to know, is that equal to 3? Let's hope so. All right, so I need to add those ninths together. So I need to basically turn that to 5/1, multiply the top and the bottom by 9 so I can get a common denominator. So I have the square root of 4/9 plus, what's 5 times 4? 45/9 plus the square root of 4/9. Now, if you can look at that and say 2/3, great. If you can't, remember, you can rewrite it as the square root of 4 over the square root of 9. Is that equal to 3? So 4 plus 45 is going to be 49/9 plus, now square root of 4 is 2, the square root of 9 is 3. We'll get there, I swear. And again, if you want to rewrite this as root 49/9, you can, or you can just say, well, the root of 49 is going to be 7 over, that's supposed to be a 7, 7/3, then that's good too, plus 2/3, is that equal to 3? Let's hope so. It sure looks like it's going to be. So 7 plus 2 is, almost said 10. 7 plus 2 is 9. 9/3, is that equal to 3? And yes, indeed, 3 is equal to 3. And we are super joyous because we've finished this amazing example.